This is lesson 3.2, rational numbers. Before we discuss what rational numbers are, first I would like for you to consider this question. How many numbers exist between 0 and 1? You might recall that between each whole number exist sets of fractions and decimals. There are an infinite amount of fractions and decimals between each whole number. Between 0 and 1, there is an infinite number of numbers. Some of these numbers are called rational numbers. Rational numbers are numbers that can be written in the form a over b, where b cannot equal 0. There are several different types of numbers that can be written in the form a over b. Let's take a look at what numbers those are. First, obviously fractions, as they already are in the form a over b, such as 5/9 or -1/2. Decimals can be written in the form a over b, but only specific types of decimals. They are terminating decimals and repeating decimals. So terminating, for example, you have 0.125 or 125 thousandths is a terminating decimal, and -7/10 is also a terminating decimal. There is an ending, it does not continue. These can be written in the form a over b. For example, for the first example of 125 thousandths, you can write that as the form a over b, like a fraction. For -7/10, you could also write that in the form a over b. The second type of decimals that are included under rational numbers category are repeating decimals, like 0.63 repeating. This can be written in the form a over b, and that would be 7 over 11 is the same as 0.63 repeating. So only terminating and repeating decimals can be written in the form a over b. Integers can also be written in the form a over b. While they are not, you can see in this list, -2, -1, 0, 1, 2, they don't look like a fraction, but I can easily make them into a fraction. I can write -2 as a fraction by putting a 1 under it. I could also do -4 over 2, that is equal to -2. Lots of different ways I can turn integers into fractions. I could do 6 over 6, that's equal to 1. Integers can be written in the form a over b. Whole numbers can also be written in the form a over b, just like in the examples I showed you above with integers. 0 can be written as basically 0 over any number is 0. Or you could write 3 over 1, that's in the form a over b. You could write 4 as 8 over 2. Those can be written in the form a over b. And finally, what we call natural numbers. These can be written in the form a over b as well. You might notice that whole numbers and natural numbers are almost identical sets of numbers. The only difference is that whole numbers include a 0. You can see that. A good way to remember that is the word whole has an O in it, and that might remind you that whole numbers include 0, but natural numbers do not include 0. All right, let's take a look at some examples of numbers and discuss what sets of numbers they fall into. So for the first example, I want to talk about the number 3. The number 3 can be written in the form a over b. We could write it as 3 over 1. We could write it as 6 over 2, etc. So the number 3 falls under several of these categories. It is a rational number. It's also an integer. It is a whole number. And it is a natural number. I can write it in each of the categories, But also, the way this Venn diagram works is that if I write it in the smallest circle of natural numbers, then that means it also fits inside of all of the bigger circles, whole, integers, and rational. Let's talk about another example like -1/2. This is in the form a over b, so we know it's rational. So I'm going to write that out here where the rational number category is. But is it an integer, a whole number, or a natural number? This is not any of those three. It is a negative number, but just because it's a negative number does not make it an integer. An integer does not have any fractions or decimals, so -1/2 is only a rational number. Let's talk about the number -7. -7 can be written in the form a over b. Again, I can just put a 1 under it, and that makes it rational. So -7 is a rational number. It is also an integer, but it is not a whole number or a natural number. So -7 belongs in these two categories. How about the decimal 0.3 repeating? 0.3 repeating, we discussed that certain types of decimals fall under the rational number category, and that are repeating decimals and terminating decimals. So 0.3 is a repeating decimal, which means it is rational, but it is not an integer, a whole number, or a natural number, so it only fits under the rational number category. Let's take a look at one more example, and that is 0.2. 0.2 is a terminating decimal, which we said is a rational number. We can write that as 2/10 or 1/5, and that is in the form a over b. That is a rational number, but it's not an integer, nor is it a whole number or a natural number. So this Venn diagram can be helpful for deciding which categories numbers fall into or which sets of numbers something falls under. Let's try some more examples without the Venn diagram. Name all sets to which each belongs. -3.5, 15, -8, 2.5, and 0. -3.85 is a rational number because it includes a terminating decimal and therefore can be written in the form a over b. It is not an integer because it has a decimal. 15 is a rational number. It's also an integer. It's also a whole number, and it's a natural number, so that fits in every single category. -8 is a rational number. It can be written as a over b, and it is an integer because there are no fractions or decimals. 2.5 is a rational number, and 0 fits under every category except one, and that is natural. So it fits under rational number, it's an integer, and it's a whole number. Give an example of a rational number. This can be almost anything. Give an example of an integer that is not a whole number or a natural number. Give an example of a whole number that is not a natural number. And give an example of a rational number that is not an integer, whole number, or natural number. I'm just going to give a few. There are several different examples for each of these. A rational number can be almost anything. Basically, for the first example, you can include any number as long as it has no, as long as it's not pi, basically. We didn't discuss this, but pi is a number decimal that never ends and never repeats. So pi does not fit under the rational number category. That's the only number that you might be familiar with as of now that wouldn't fit there. So you could put anything, 1/2, 0.782, -4, -4/5, -10, 256, lots of different options for that first one. For the second one, an integer that is not a whole number or natural number would be something like -4. So a negative number with no decimals, anything like that would work for number 2. For the third one, a whole number that is not a natural number, there is only one answer for this one, and that is 0. Every other whole number is also a natural number. So 0 is the only possible answer for number 3. And for number 4, a rational number that's not an integer, whole number, or natural, and that would be anything that has a fraction or a decimal. So -2/3, 0.6 repeating, -1.4 repeating, 2.5, anything with a fraction or decimal would work for that last one.